Rule-based programming means doing things by applying rules that replace one expression with another. For example, here's a rule-based program that distributes a function g over addition by applying a rule that replaces anything that matches the pattern g of p plus q with g of p plus g of q. The slash dot operator in that input is a special notation for the replace all function. The replace all function applies the rule only once to each subexpression, so for example, it does not continue distributing g over addition after the first application of the rule. To keep applying the rule, there is another function called replace repeated that keeps applying rules until the expression stops changing. For example, this shows that same rule applied using replace repeated, which keeps applying the rule until the function g is distributed over all of the sums. The replace repeated function can also be entered using the / dot operator. Multiple rules can be applied using lists of rules. For example, here's an extension of that program to include a second rule that factors an integer coefficient from the arguments of g. Rule-based programming is especially common in applications like this one, where there is a clear way to specify the program as a set of rules. Rule-based programming can also be done using assignments. For example, these assignments set up that same program by introducing a pair of evaluation rules. The evaluation rules are applied automatically as part of evaluation to get the same result as the earlier result from replace repeated, and like replace repeated, evaluation keeps applying rules until the result stops changing. Since evaluation rules apply to every evaluation, assignments and evaluation rules are typically used only to introduce rules that should be available broadly throughout an application. Evaluation rules that are no longer needed can be cleared using the clear function. One somewhat technical difference between evaluation and replace repeated is a difference that applies when there are rules that can be used in more than one way. For example, the rule in this input can be applied either to the entire expression or to the argument of that expression. The replace repeated function works by first looking for rules that apply to the outermost expression before it considers the elements of that expression, and so in this example the rule is applied to the entire expression. If the same rule is entered using an assignment, however, the evaluation rule is applied to the argument of the outermost expression. This difference is basically a consequence of the standard order of evaluation, where evaluation rules are applied to the elements of an expression before they are applied to the enclosing expression. Another difference between evaluation and replace repeated is a difference that applies to examples like this one, where the ordering of rules is important. In this example, the rule for f of 0 must be tried first so that the rule for f of n doesn't get used until after the rule for f of 0 has been tested. Replace repeated applies rules in the order in which they are listed, so if the rules are listed in the opposite order, replace repeated keeps applying the first rule over and over. The limit on the number of times that a rule will be applied by replace repeated is controlled by the max iterations option. If that same program is entered using assignments, however, the system automatically puts the more specific rule, which here is the rule for f of 0, ahead of the more general rule, so that this evaluation will work regardless of the order that the assignments were entered. The ordering of the evaluation rules is also shown in the result from $f. And as already noted, rules that are no longer needed can be cleared using the clear function. In addition to replace all, which applies a rule once, as in this example, and replace repeated, which applies a rule until the expression stops changing, it is sometimes useful to control the number of times that a rule is applied. And one convenient way to do that is with the nest or nest list functions. For example, this shows nest list with replace all in a pure function, giving results after 1, 2, and 3 applications of the rule. Replace all can also be used in an operator form. For example, this application of the rule using a pure function can also be written in an operator form, and using the operator form of replace all, the earlier nest list input can be written like this. In this example, repeated application of the rules eventually reaches a fixed point where the expression stops changing. The fixed point result can be obtained using the fixed point list function, which gives the same result as nest list but stops as soon as the expression stops changing. There's also a function fixed point that gives the last element in the result from fixed point list. This shows the same result obtained using replace repeated. In most examples, replace repeated is equivalent to a combination like this one of fixed point and replace all. In addition to replace all and replace repeated, there are several other functions that apply replacement rules. One basic function is replace. This shows replace used to replace A with B. Replace takes an optional third argument that works as a level specification. For example, this input uses 1 as a level specification so that replace does replacements for the elements of this list, which are the expressions at level 1. The rules in this example just swap the A's and the B's. Replacements are not done for other levels in the expression. For example, the A and the B in the sublist in this example, which are at level 2, are not swapped. The level specification can also be all, which causes replace to make replacements at all levels in the expression. Replace with all as the level specification is similar to the replace all function and does give the same result in this example, but these operations are not always the same. The difference between the two is similar to the difference between replace all and application of evaluation rules. Specifically, using again the example that came up earlier when rules can be applied in more than one way, replace with all as the level specification applies rules to the innermost expression, which is similar to how evaluation works, while replace all applies rules to the outermost expression. There are a few other functions that apply replacement rules and that are worth knowing about. One of those functions is sequence replace, shown here with a rule that replaces sequences consisting of a 3 and the element that follows the 3 in a list. Sequence replace makes replacements specifically in lists and is designed for replacing sequences of the elements in a list. Another interesting function is replace list, which returns a list of all possible ways for a rule to be applied to an entire expression. For example, this shows replace list giving a result that also picks out elements that follow a 3 in a list, as in the previous example, but replace list does this using a pattern that can match the list in 3 different ways. Replace list is useful in many other situations as well. For example, this shows replace list returning all possible matches for a pattern affected by the orderless attribute, which allows the pattern to match elements in any order. There are also several functions for working with strings, one of which is string replace, shown here making a replacement for characters in a string. The left side of the rule in that example uses white space and the string pattern operator, both of which are part of a language for representing string patterns. That's the end of the examples for this section. In the Wolfram Documentation Center, there's a link to the guide page on rules and patterns, which is a list of links to documentation for most of the functions that came up in this section. For a more tutorial discussion of rule-based programming, there is this tech note on patterns and transformation rules, and this tech note on transformation rules and definitions.